Hi everyone, this is Miss Afric, and today we're going to start our new unit, Unit 5, and start talking about exponential graphs. Alright, we've been talking about the graphs of a bunch of different functions so far, like linear graphs, graphs of quadratics, so parabolas. We did rational graphs last semester. We've done square root and cube root graphs, right? So now we're just going to add one other kind of graph to this, and that's an exponential graph. Alright, so here is the general form for an exponential growth and decay equation. So maybe pause the video and jot this stuff down so that you can then also pay attention to what I'm saying. Alright, in the general form of an exponential growth and decay equation, what's important to note is that the reason we call it exponential is because our variable, so x, is in the exponent. That's what defines something as an exponential equation. So the variable is in the exponent. Alright, so right here, that x, right, that is our variable. Okay, that means everything else in this equation represents something. So the a value, the one we first write down, that's our initial amount. So that's what something starts as. B, the number that that's our base, right? This is kind of like our base of that exponent. That's our growth factor. So that tells us kind of how much something is growing by, right? And then y, whatever this final number is that it equals, that's going to be our final amount. All right, we're going to be looking for a few different things in the next question. Number one, we're going to be trying to figure out if it's going to be growth or decay, because remember, we've got those two different kinds of things. We're going to find the initial amount and the percent increasing decrease. All right, so let's start with whether it's growth or decay. Growth would mean that this number in there has to be greater than 1, all right, because that means it's going to be getting bigger. So the absolute value of our growth factor, or I suppose that could be decay factor also, we should add that in. All right, one or the other. If that number is greater than 1, then that's going to be exponential growth. All right, whereas if that number is going to be smaller than 1, that would be decay. All right, so it won't be too hard to tell. The other part that's really important is being able to tell what percentage it's growing by or decaying by. All right, so the idea is we always start with 100% and then we add or subtract from there. So to find the percent that we're increasing or decreasing by, we want to know how far away b is from 1, from that 100% value. So we'll either do 1 minus b or b minus 1, depending on which number is bigger. So let's try a few problems. All right, it says determine if the following equation is exponential growth or decay. Determine the initial amount and the percent increase or decrease. All right, so for letter A, we have y equals 2 times 0.23 to the x. So this 2 is our a value. 0.23 is b. All right, so the first thing it wants to know is whether it's growth or decay. Well, since b, the absolute value of 0.23, since that is just 0.23, and that's smaller than 1, when it's smaller than 1, that means it's going to be decreasing. So this would be exponential decay. Decay is decreasing. All right, so exponential decay. So there's the answer to the first part. Then it asks us for the initial amount. The initial amount is that front number. So in this, the a value, right? In this case, that would be 2. So I'm going to, whoops, that is not how you spell initial. I'm going to say my initial amount is 2. All right, the last thing is my percent increase or decrease. So again, remember, this number inside, it's like it starts with 100%, and then we decrease or increase. So we need to know how far away this number is from that 100%, or in other words, just from 1. So to figure out my percent increase or decrease, well, in this case, since it's decay, it'll be a percent decrease. All right, to figure that out, I'm going to take that 0.23 and subtract it from 1. All right. That tells me how far away 0.23 is from 1. So 1 minus 0.23, you can use your calculator if you need to. It should be 0.77. And then since I want the percent, I'm just going to multiply by 100 to get 77%. So that's my percent decrease. All right, not so bad. Let's try with letter B. So same idea. Let's see, I need to find my a and b. Well, there's no number here. So do you remember what you're multiplying by if it's not written down? Hopefully you said 1, because that would be right. right? If we don't have a value that we're multiplying by, then it's just times 1. So 1 is our A value, 1.56 is our B. So since the absolute value of our B value is greater than 1, right, because that equals 1.56. Oops. Alright, let's try that again. There we go. So that equals 1.56. Since that's greater than 1, this would be exponential growth, because that means it's increasing from that 100%. Alright, our initial value, remember what we mentioned, if there's no number there, that's really a 1. So our initial value, what we're starting at, is going to be just 1. And the last piece is my percent increase or decrease. Since it's growth, we are going to be increasing, so it's a percent increase. Alright, and to figure that out, we want to know how far away 1.56 is from 100%, or 1. Alright, since 1.56 is bigger than 1, I'm going to start with that and then subtract 1. I always want that number to be positive, so that's why I always start with the bigger number. Alright, we get 0.56, so that means my percent increase would be 56%. Alright, not so bad. So now we're going to get into graphing, and I'm going to do some of it here, and then we'll do some of it in class also. Okay, when it comes to graphing, our parent function that we're going to use, right, is just y equals b to the x. Right, that's just the general form of the equation, where b is our base, and that base can technically be any number at all. Alright, now in order to graph these, we can use our calculator to help us out if need be. But otherwise, there's really just 3 things that we're going to be graphing. We're going to graph 2 key points, and then we're going to graph an asymptote. These graphs have an asymptote. Remember, that's like a line that your graph should never cross. All right. The 2 key points for any exponential function are going to be 0, 1, and 1, b. Does that make sense why those would be points? Let's check. So remember, this is x and this is y. So if I plug 0 in for x, we get b to the 0. Well, what's anything to the 0 power? Just 1. Alright, so that one makes sense. And same idea here. This 1 would be x, b would be y. If I plug 1 in for x, I would get b to the 1st. Well, that's just b. Alright, so these points should make sense. And then our asymptote. This one's a little trickier, but keep in mind that when I raise a number to an exponent, the answer to that can never be negative. Right? That would never happen because negative exponents make fractions. They don't make negative numbers. Right? So our asymptote is saying that y cannot pass 0. In fact, it'll never equal 0 or go past 0. Alright? Now here's the tricky part. This is just the parent function. We can still have transformations on it. So I'm going to make a little side note over here to talk about the transformations that we could see. Alright, that would mean, for example, we could have a number in front, that a value that we talked about before. We could have a minus h with x, right, up in the exponent. And we could have a plus k on the end. So these would be the 3 different transformations that we could have. So let's just make sure we remember what those transformations represent. All right, if a is negative, then that would be a vertical reflection over the x-axis. All right, if a, the absolute value of a, is bigger than 1, that's a vertical expansion. And if a is smaller than 1, it's a vertical compression, because compression means get smaller, and expansion means get bigger. Alright, so A is the most complicated one because there's a few different situations. But H and K aren't so bad. H just tells you how much to shift. Alright, so it's a horizontal shift, left or right. And remember, it's opposite. Alright, and then K is what K's always been, and that's a vertical shift, up or down. Okay, so let's try describing some transformations, and let's see if we can get that key point and that asymptote. All right, for example 2, describe the transformations of the parent function f of x equals 3 to the x. Identify the key point and asymptote. Now here's what's most important. Those key points that we talked about up here, those are going to adjust based on your transformations. All right, so what we're going to do is we're going to write down what the parent function's key points are. Then after we describe the transformations, we'll try and figure out our actual key points. All right, so this parent function, since it's 3 to the x, my two key points would be the points 0, 1 still, and then 1, 3, since my base is 3. So for number 2a, let's start with. If I want to describe my transformations, I start with horizontal, but there are none. So I go left to right with vertical. So there's a negative, that would be a vertical reflection over the x-axis. All right, and then I move on to the +1. That's a vertical shift up 1. All right, so now's the hard part, and this is where we have to identify our key point and asymptote. Oh, you know what? I should come up with the asymptote of this parent function also. This one would just be y equals 0, because that's what it always starts as, y equals 0. Okay, so now that I know my starting values, I have to use my transformations to shift them. So for example, a vertical reflection over the x-axis would mean I would make y a negative y, because that's what reflections do. They make things negative. And a vertical shift up 1 would mean I would add 1 to y. So that's how I'm going to be shifting the y values. Now, did I have any horizontal transformations? Nope. So x is going to stay the same. So now I'm going to take these 2 points here, and I'm going to use these ideas, these transformations, to help me fix them. All right. So for the point 0, 1, the x is 0, and x stays the same, so it's still 0. But the y is 1, and this says that in order to make my new y, I have to make it negative, so negative 1, and then I have to add 1. Well, negative 1 plus 1, that's 0. So there's my first key point. Oops. So key points, first one is going to be 0, 0. All right, for my second one, the x again stays the same, and the y is going to be 3, so that means I need to make it negative, so negative 3. And then I have to add 1, so that would become negative 2. So my second key point is 1, negative 2. And those are my 2 key points. So see how we started with the originals, but then we used our transformations to shift them. That's how we're always going to be graphing. All right, when it comes to the asymptote, since the asymptote is y equals 0, that means I have to look at my y transformations to see how to shift it. All right, so if y is 0, I have to make 0 negative, which is still 0. And then I have to add 1. So my new asymptote would be y equals 1. And there we have it. All right. I know this part's a little tricky, so feel free to write down any questions you have. We're going to talk more about it in class tomorrow. All right, so I'm actually going to stop there. We'll go over this one in class. All right, and for now, just again, go back and rewatch if you need to, review some of the transformations if you need to, and write down any and all questions that you might have. All right, your notes should look something like mine. Everything I wrote down is very important, so you want to make sure it's written down in your notes too. All right, I'll see you later.